This video is going to be about how to do the stoichiometry stations lab. At this lab, you're going to have to be able to solve stoichiometry problems using dimensional analysis. And we have an example problem right here that's going to be pretty similar to the problems that you're doing during the lab. All right. We're going to follow the same kind of steps that we would normally do during any dimensional analysis problem, and I have them on this sheet of paper right here. You're first going to identify your starting amount and ending unit in the problem. You're going to write your starting amount and write your ending unit. You're going to use Mohs-Moll and identify the path, so this is the Mohs-Moll map. You're going to choose conversion factors, and finally you're going to calculate your answer. So if we see in this problem right here, the first thing we have to do is identify our starting amount. The sheet of paper that you're going to be using during your lab is laminated, so you shouldn't write on it. So you're going to have to write on a separate sheet of paper, so that's what I'm going to try right now. First of all, identify the starting amount. Well, the number in the problem is 51 grams, and it's really important now that we also include the substance that's with it. So it's 51 grams of ammonia gas. So 51 grams NH3 is the starting amount. That's going to be the amount that goes over 1 at the beginning of the problem. And if you notice here in the example, it's already given to you. We're also going to want to write our ending unit. What unit do we want to go to? And in this case, the problem is asking us for grams. How many grams of hydrogen gas? So I underline that. You can't underline it, but you can write it. So grams of hydrogen gas. Notice that it's really important that you write the unit and the substance for each the starting and the ending amount. Okay, so I wrote both of them, and now I'm going to go to identify the path on Mohs-Moll. All right, I'm going to zoom in for this so you can see a little bit better. And if you see on this piece of paper right here, we have Mohs-Moll. It's not the best print job I've ever done, so I'm going to try to just get it to be resolved a little bit better. So you'll notice that the starting unit is grams, and I have a number in grams. The ending unit is grams, and I have a number of grams. And so in Mohs-Moll, grams is our starting amount. Well, if I'm going to go to grams, does that mean I'm going to exactly the same place? Probably not. I'm going to be going to grams on the other side of the mall, because this other side of the mall is all about the new substance. In this case, H2 is the new substance that we're trying to find for our answer. The beginning unit that we're dealing with right here, I apologize, I'm trying to focus a little better for you guys. The beginning side of the mall is all about NH3. So this entire side of the mall is about the original substance in the problem, NH3. So we have grams of NH3, and we're going to be going to grams of H2. In order to be able to do that, we have to identify the path through the mall. And if you notice, we have to go first to moles, then to moles on the other side, and then up to grams again. And so the conversion factors I'm using are molar mass, mole ratio, and molar mass again. So now it's time to choose those conversion factors. So I zoomed out again for you guys. Let's try to make this be the full size of the screen so you can see a little bit better. All right, at your stations, you're going to have conversion factors that are on pieces of paper. And so if you notice, there's a bunch of them, and then there's some little slips with just moles, and a bunch more, and a bunch more. Now, if you remember, we had to use molar mass, and then mole ratio, and then molar mass. So again, look at all the conversions. Which one do I use? Oh my goodness. That's actually the point of this activity, is to try to figure out which conversion factor to use. So if you notice at the beginning, I have grams NH3. So I have to cancel grams NH3. Which of these conversion factors has grams NH3? If you notice, the green ones are all the NH3 ones. So we really just need to narrow it down to that. It's not going to be liters or liters. Let's get rid of those. So it's going to be either this one or this one. Grams NH3 or grams NH3 that goes in that first conversion. And which one goes in the denominator is the one that cancels. So this is the one with grams of NH3 in the denominator. That's the molar mass of NH3. So I'm going to slide that up into place. All right. In terms of Mohs-Moll, I've now gone from grams to moles. So I'm here now. And I need to get to moles on the other side. In order to be able to do that, I need to use the mole ratio. We learned that mole ratios are ratios of moles from the problem, from the original equation. And so if you notice, 2 NH3 in the original equation means 2 moles NH3. 3 H2 means 3 moles H2. And N2 right here means 1 mole N2. So again, we're going to be interpreting that balanced equation in terms of moles. Balanced chemical equations are recipes written in moles. So the purpose of doing this next conversion is going to be to go from moles of NH3 to moles of the final answer, and that would be hydrogen. So I want to cancel NH3 on the bottom, and I want to go to H2 on the top. All right, if we finished the problem right now, we would be in moles of H2. Notice our new substance. We got to do that last step to get to grams of H2. And so if I want to figure out how to go to grams of H2, you notice yellow is H2, and I don't want to use the volumes, so I'm not going to use those because we don't want to go to liters. I'm going to clear away a bunch of these other pieces of paper right now. And so I'm pretty much deciding between this conversion and this conversion. Those are both the molar mass of H2. And the one I want to use is the one that cancels moles, so that one on the top. All right, the final trick right here is we're going to have to calculate our answer. So far, we have identified the starting and ending unit. We use mol as a map to identify the bath. We chose our conversion factors and just calculate our answer. And so I'm going to multiply across the top, multiply across the bottom, and divide. So you won't be able to see this well just because of the shadows on the calculator. But I'm going to do 51 times 1 times 3 times 2. And I'm going to divide by the quantity, so I'm using parentheses, 17 times 2 times 1. And I got 9. I'm writing it on the paper here. You can't. Well, 9 what? The only units that haven't canceled now are grams in H2. So that's going to be 9 grams H2. So to recap, 51 grams NH3 makes 9 grams H2, or actually comes from 9 grams H2. This kind of math doesn't actually care whether you're a reactant or a product. It just matters that they're in ratio to each other. All right, so we use molar mass to get to moles. Then we use the mole ratio because, remember, if in doubt, mole it out. That gets us to moles. And then finally, we're going to use the molar mass to get back into the grams that we want. Thank you for watching.